Okay, welcome to Introduction to Transformations. So today what we're going to be doing is we're going to be talking about transformations. There are 4 different types of transformations. We're just going to go through those examples together now. One of them is called a translation, and a translation is a transformation that moves a shape, left, right, up, or down. So if we're here with letter A and we want to move it from letter A to letter A, that's a translation. We've moved this shape up. Reflection is a transformation that flips a figure. So you can think of a reflection as like a mirror, right? Whatever you see in one side, you also see in the other. So it's a direct reflection. A rotation is something that turns a figure. So if we have the letter A like this, but then we turn it to be like this is called a rotation. And then we have something called a dilation, which enlarges or makes bigger, or reduces or makes smaller. So if we have the letter A and the letter A, that's a dilation, or letter A and letter A, right? So that's a dilation. So these are the different types of transformations. So now let's do the do now. Use the definition above to determine which type of transformation is taking place. So a triangle is moved 3 units to the right. So we have this triangle and it's moved 1, 2, 3 units. Nothing else changes about the triangle, it's just moved. This is called a translation. We have a square that's enlarged to be 2 times the original. So here we have a square and then it's enlarged. So now it's 2 times. The size has changed. Whenever size changes, that is an example of a dilation. And then we have an example of a star. So we have a star. We're flipping it over the x-axis. So it's moving over. That is an example of a reflection. Let's get into the lesson. So we have some vocabulary definitions we're going to match. So transformation. A transformation, let's look at these definitions. Let's actually start with the definitions and then we'll see if we can find the word. It makes it easier. So the new figure after a transformation. So once a transformation happens, the new figure is called an image. Okay, so 5 would be A. A transformation that changes the size. So yes, we know it's now a dilation, right? Dilations change the size, but any transformation that changes a size is called a non-rigid transformation. And that just basically means that it's changing size. A movement of a figure in a plane is called a transformation. So remember all of those, right? We had reflection, we had rotation, we had dilation and translation. All of these are different types of transformations. And anytime you move something in a plane, it's called a transformation. And a plane is just another word for a grid, right? A coordinate plane. This is, you guys probably remember this, right? The X and the Y axis. Okay, so now we're going to go to this D. A transformation that keeps the shape the same size is called a rigid transformation. So non-rigid, not same size. Rigid, same size. And then the original figure right here is called a pre-image. Think about the word pre as like before. Okay, so now we have some definitions under our belt. So now we're going to just practice some stuff here. So identifying transformations. A triangle slides 5 units to the right. What type of transformation is that? Remember, transformations are, we'll write them again, with translations, dilations, reflections, and rotations. So these are the words we're thinking of right now. So if it slides to the right, that is an example of a translation. And you can pause this video and you can try them on your own and then come back and see if you're correct. A rectangle flips over the y-axis. That's an example of a reflection. A pentagon rotates. That was an easy one, right? The word rotates is in there. Turns would be another word for rotation, but this is an example of a rotation. And let's just talk about counterclockwise for a second, right? What does that mean? If we have a clock, right? We have this clock. Clockwise would be like how you read a clock, right? This way is called clockwise, right? Because you read a clock like that. Counterclockwise is the opposite direction, which means that when we shift or turn a shape, we're turning it counterclockwise, which is going to be this way, or we're turning it clockwise, which is the way you read a clock. That's how I like to remember it. And then a square becomes twice its size is an example of a dilation, right? If something is 2 times the size, it is bigger. So now let's look. What do the first 3 transformations have in common? So what do these guys right here have in common? Well, if we look back to our definitions, we can see that what's happening with these guys. These guys are not changing size, right? So translations, reflections, and rotations do not change the size of a shape, which means that these guys are all called rigid transformations, right? They are all rigid transformations. And let's write why. Because size doesn't change. And again, pause the video, copy what you need, and then come back. How does a dilation differ from the others? The dilation differs from the others because they change the size. Great. Okay, so now how does a dilation differ from the others? A dilation differs from the others because a dilation changes the size of the shape, right? And we know, if we look back, anything that changes the size of a shape is called a non-rigid transformation. So dilations are an example of a non-rigid transformation. And then how can you tell if a transformation preserves congruence? There's a lot of words in this, so let's talk about it. Preserves means to stay the same, right? Preserves means keeps it. Congruence means equals. Okay? So how can you tell if a transformation is going to keep the shape the same? It's basically if it's a rigid transformation. So now we know that translations, reflections, and rotations will not change the shape. So if you see that a shape is getting translated, reflected, or rotated, we know that the shapes are going to remain equal. So how can you tell if a transformation preserves congruence? If the shape goes through a rigid transformation, the shapes will be congruent. Okay, so watch this video as many times as you need, and what you guys are going to do now is you're going to practice. You're going to do all these questions. You're going to figure out if it's what type of transformation and if it's rigid or non-rigid, and then over here you're going to do the same thing, and at the end here there's a little challenge question for you to complete.